These next few videos, we're going to look at some other types of equations. In this video, we're going to look at rational equations. We have seen this already in a previous video, but a rational equation is an equation that we have fractions, typically with variables in the denominator. A very common approach to solving rational equations is by clearing the fractions by multiplying through by an LCD. But when we have a rational equation, we do have to check our answers against any restrictions. So we really need to know where any of the fraction terms in our equation are undefined. So let's just talk about being undefined. If we have a rational expression, this is an expression, not a function. 5x minus 3 divided by x squared minus 16. And we want to know where it's undefined. It's going to be undefined where your denominator equals 0. So we're going to set up the equation x squared minus 16 equals 0. Add 16 to both sides, we get x squared equals 16. And here, to undo that exponent of 2, that square, what we're going to do is take the square root of both sides. But when we take the square root of both sides to isolate x, we have to add that plus or minus. So then we get x is equal to plus or minus 4. So there are two values that make that denominator equal to 0. Again, just to summarize, when we take the square root like we did to undo a square, that's when you have to add the plus or minus. If the square root's already present, you don't need to add the plus or minus. It's implied it's a positive root. All right, so looking at the next example, 3 divided by x minus 2 plus 4 divided by x minus 3 equals 2x divided by x squared minus 5x plus 6. We're going to try to identify the LCD, the least common denominator. In order to do that, we want to make sure that we have all of our denominators factored. So if we look at the third fraction, that denominator x squared minus 5x plus 6, we want to factor that. Factors of 6 that sum to -5, that's going to be -3 and -2. So now that everything is factored, we can see that our LCD is going to be x minus 2 times x minus 3. And we can also see our restrictions. X cannot be 2, because if it's 2, that first denominator is 0, and so is the third. And it can't be 3. So those are our restrictions. So when we solve our equation, because once we clear out those fractions, we're not going to have, we're going to end up with something either linear or quadratic, some polynomial equation that doesn't have any restrictions. We have to check against the original to make sure that the solutions we get from that modified equation is still within the solution of, or the possible solution set of the original equation. So now that we have our LCD, we're going to multiply each term in our equation by that LCD. X minus 2 times x minus 3 times 3 over x minus 2 plus x minus 2 times x minus 3 times 4 over x minus 3 equals x minus 2 times x minus 3 times 2x over x minus 2 times x minus 3. I like to show that distribution because it allows me to simplify each term individually. So in the first term, my x minus 2s are going to simplify to 1. In the second term, our x minus 3s simplify to 1. And in our last term, both the x minus 2 and the x minus 3 are going to simplify to 1 because of those like factors in the denominator. So we're left with 3 times x minus 3 plus 4 times x minus 2 equals 2x. This is a very straightforward linear equation. We're going to distribute 3x minus 9 plus 4x minus 8 equals 2x. Combine like terms on the left-hand side. 3x plus 4x is 7x. -9 minus 8 is -17. equals 2x. We're going to subtract 7x from both sides because we want to get those like terms together. So here's a great example. I've talked about this in other videos. We're not going to be able to avoid a negative coefficient on x in this situation, not without adding additional steps anyway. So having a negative coefficient on x is okay. If we can avoid it, awesome. So we have negative 17 equals negative 5x. Dividing both sides by negative 5, and I'm going to write this out just so I'm careful with my signs. We get that x is equal to positive 17 over 5, which, checking against my restrictions 2 and 3, this is not either one of those restrictions, so we're going to assume that that solution is correct. We could plug that back into the original to check it, but what we're really making sure is that our solution isn't one of those original restrictions. Negative 5 plus x divided by x minus 9 equals 9 divided by x minus 9. Our LCD is x minus 9. And looking at our denominators, we only have a denominator of x minus 9. So our restriction is going to be positive 9 because that's where either of those two denominators would be equal to 0. So again, I'm going to distribute that least common denominator to all terms. And that, again, allows me to just simplify each term individually without having to keep track of what's canceled out and what hasn't. So in that first term, since we don't have a denominator, nothing simplifies out. The second term, the x minus 9 simplify out. And in the last term, the x minus 9 simplify out. So we've got negative 5 times x minus 9. We're going to distribute it. I know it's set up a little backwards, but that's okay. We're just distributing that negative 5 to the x and the negative 9. So we have negative 5x plus 45 plus x equals 9. Simplify on the left-hand side. Negative 5x plus x is negative 4x plus 45 equals 9. We're going to subtract 45 from both sides. So negative 4x is equal to negative 36. Divide both sides by negative 4. X is equal to negative 36 divided by negative 4 is positive 9. However, since our restriction was x, oh, sorry, this should have been x cannot equal 9. That is not a solution. So this equation does not have a solution. X plus 3x plus 5 over x plus 5 equals 2x over x plus 5. Our LCD is going to be x plus 5. And our restrictions, x cannot equal negative 5. That's going to be what makes either of those two denominators equal to 0. Multiplying through by my LCD, we have x plus 5 times x plus x plus 5 times 3x plus 5 over x plus 5 equals x plus 5 times 2x over x plus 5. And we simplify. Then in our next line, we're going to simplify the equation. We've got x squared plus 5x plus 3x plus 5 equals 2x. Observing that x squared term, I'm thinking this is a quadratic, so my go-to technique is to set this equal to 0. So I'm going to combine like terms and set this equal to 0 all in one step. So we've got x squared plus 5x plus 3x is 8x, but then I'm going to subtract the 2x, so we get plus 6x plus 5 equals 0. We're going to try factoring first. Factors of 5, that sum to 6. 5 and 1, both are positive. When we set each of these factors equal to 0, we get x is equal to -5 and x is equal to +1. I'm sorry, -1. Looking at our restrictions, we do have a restriction of -5. So that is an extraneous solution. Our only solution is x equals -1. Four x divided by x plus 1 minus 5 divided by x equals 4 over x squared plus x. So here's another example where we're going to start by factoring that third denominator, the x squared plus x. Factoring the denominators just makes it a lot easier for us to identify what that LCD is. So from x squared plus x, I can factor out an x, and I'm left with x plus 1. From there, I can see that my least common denominator is x times x plus 1. And my restrictions, x cannot equal -1 from that first fraction. It also can't equal 0. And we see both of those restrictions from that third fraction as well. So I'm going to start multiplying the entire fraction by my LCD. I have x times x plus 1 times 4x over x plus 1 plus x times x plus 1 times 5 over x. I realized I made a typo. This should be a minus here. Equals x times x plus 1 times 4 over x squared plus x. Actually, I'm going to write it as my factored form because it's a little bit easier to see that way. The simplifying. So simplifying in the first term, my x plus 1 simplify to 1. My second fraction, the x over x simplify to 1. And in my third fraction, the x times the x plus 1 both simplify out. So rewriting this, we've got x times 4x, which is 4x squared, minus 5 times x plus 1. I'm going to, knowing myself, knowing that there's that minus sign, I don't want to be trying to keep track of it, so I'll simplify that in the next step. Equals 4. Now I'm going to distribute minus 5x minus 5 equals 4. Again, looking like a quadratic, so I'm going to set this equal to 0. 4x squared minus 5x. Subtracting 4 from both sides, we get minus 9 equals 0. I'm always going to attempt to factor first. I've been factoring for a really long time, so I can factor really quickly. If you are struggling with the factoring, you could always opt for using the quadratic formula. It's just a bit more time consuming. But ideally, you are working on those factoring skills and getting a little bit quicker at it. So 4x squared minus 5x minus 9. I'm going to try 4x and x. And then I'm going to try 9 and 1. Because if I set this up, I've got a 4x and a 9x, which could give me 5x if I have the right sign. So let's try some signs. We know we need -9. So one of the signs is going to be positive, the other is going to be negative. We need a -5x. So I want the 9 to be the negative and the 4x to be positive. And we can do a quick check just to make sure that we've done this correctly. 4x squared plus 4x minus 9x is -5x minus 9. Looking good. Setting both of these factors to 0, we would get x equals 9 over 4, or x equals -1. X equals -1 is one of our restrictions that we stated at the beginning, so that's an extraneous solution. Our only solution is 9 over 4.